Hello, and welcome to this wonderful webinar put together in collaboration between Lead Semantics and Ontotext. Today, we're going to be discussing 3 ways to ensure projects succeed when implementing knowledge graph and LLMs, particularly in the fields of legal and news. We may come across different examples from other industries, but we're going to primarily stick to these areas. I'm going to be moderating. My name is Joaquin Malata, and I'm the founder of the Swarm community. The 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 main show will be hosted by Prasad Yalamanchi of Lead Semantics and Sumit Paul of Ontotext. If you guys would like to give a brief introduction, the mic is yours.
Yeah, I am Prasad Yalamanchi, founder CEO of Lead Semantics. We are the developer of Text Distill, which is a text to knowledge graph pipeline software. And we operate in various domains. That's the brief introduction. Sumit?
Oh, you're on mute, Sumit.
Thank you, Prasad. And hi, my name is Sumit. I am an ex-Gartner analyst in the data management and analytics space with a wide coverage of things around from data lakes, lakehouses, graph databases, time series databases, and all that. And my role here at Ontotext straddles between marketing, pre-sales, solutions engineering, to bring in thought leadership across various industries and evangelize the usage of knowledge graphs and semantic technologies. So that's in short about myself.
Great. Well, let's lay the foundation for the rest of this conversation. I think we can contextualize it by starting with what is knowledge? I think that is one of the key words of the last year. How do we reason with knowledge? How do we bring knowledge to the enterprise? So, yeah, Prasad.
Yeah, thank you, Joaquin. So the contemporary noise that's being going around in the market is about language most of the time, and it turns out language by itself is not knowledge. Language is a mechanism to communicate knowledge, and so wherever language is there, there is knowledge to be had, knowledge to be extracted. One way or another, language is used to communicate, and so from that sense, knowledge is this other thing that is coming through language, and all the big GPT, GPT-3 and generative AI, they're all producing language, but that out of that language, we would have to kind of really make an effort to get at the knowledge, so to speak. Knowledge is what we accumulate, and it is kind of manufactured, it's understood, it is negotiated between communities, and all of that stuff. So I will leave it for the rest of the discussion, and Sumit will have definitely things to add to this.
Sure. Thank you, Prasad. Yes, and knowledge is, in my opinion, when you do search, for example, in any search engine, right? You, for example, search for Albert Einstein in Google, and on the right-hand side, on the left-hand side, you get the results based on what you searched. But on the right-hand side, you get more information about that particular thing that you were searching, right? A conceptual description. So when you search for Albert Einstein, you get a lot more things about him. Where was he born? When was he born? The place where where he was born, and things around this. And that is the context. That is the knowledge associated, right? And that's why one of the reasons way back in 2012, Google changed its algorithm from doing inverted index searching, which is searching just with strings, to searching with more concepts, with things. That is where the knowledge comes, right? And in today's world, organizations need to rethink their strategies for a very fast, accelerating future as we see it's coming. And what I have seen is, there is this pyramid, which is called at the lowest layer is the data, then comes the information, then comes knowledge, and from knowledge comes the wisdom, right? It goes like a pyramid. Most organizations collect a lot of data in data lakes, and then they get some information doing ETL and doing some transformations. But unfortunately, irrespective of the kind of technologies they are using, they remain in that information layer and they fail to go to that knowledge layer. There is a huge chasm. And one of the main reason is organizations are stuck to this idea about being data driven, whereas they should be more thinking about how can we become knowledge driven. And in my understanding, what I've seen is data is abundant in current architectures, but knowledge is not. And that's why a lot of data lakes become data swamps, and information or knowledge is getting increasingly difficult to find in this sea of data. And data becomes meaningful only when you can interpret it. And the knowledge and the context gives that meaning, in my opinion.
Yeah,
I think
absolutely. Yeah.
I think collectively you painted this picture that not all language is created equal, and that knowledge and language aren't always representing the truth. I think that third aspect, context, is very important. And if we don't contextualize information, it's not realized knowledge. So what are these challenges that we have to overcome to be able to interact with this knowledge? How do we work with unstructured data, particularly because that's how we communicate with each other via email, via documents, PowerPoints, books. I think it's a medium of knowledge.
Yeah. I'll start by focusing on the terminology here. I think we kind of get mixed up with information and knowledge quite a bit. Information is not knowledge yet, as Sumit was saying. There is something that is missing between information to knowledge. I mean, much as data to information, right? I mean, with data, you have to add something more before it really is information for you to kind of start doing something with it, and that is the so-called context. And between information to knowledge is where you add meaning. Meaning is something that as a humans, we react to meaning. That is what we are looking for. Otherwise, just pieces of bits and pieces of some number that says this is the length of something is not enough for us. We need the overall, the meaning of what it is purporting to kind of communicate. And that what makes it as knowledge. And once it becomes knowledge, then it is actionable. Knowledge is one of those, one of the big traits of knowledge is that it is actionable. That is one of those things. One is identification of certain something in the world, and then what else, additional properties that it may have, attributes and things like that. And what can you do with it? And these are the driving forces of for you to demarcate something as, okay, this is usable knowledge and not. And these pieces, as they are missing, then they are gaps. And you mentioned text and language as well, Joaquin. And text and language, which is another form of language, is the dominant way that knowledge gets communicated. Is a de facto way of communicating knowledge, and that is totally laden. I have spoken elsewhere. Text and language are like laden with knowledge, and so up until now, text has been is the fundamental mechanism of transporting language knowledge, and between people it has done its job. I mean, it continues to do its job, much as what we're accomplishing here. But so much of this text gets floated around in an enterprise, and all the knowledge that now we come to expect is there in this text is really not extracted to the point where it is structured and organized for it to participate in all the decision making processes automatically. And so that is the piece that is extreme value. If you can extract this knowledge out of this text that is ubiquitous and all around, all of that now becomes available for you to make it participate in the decision process of the enterprise.
Yeah, that's thank you, Prasad, for giving that explanation and clearly delineating things between information and knowledge and where that knowledge comes from, right? And yes, unstructured data is again all around us, right? We are just swimming in swathes of unstructured data, and unstructured data means multiple things, right? It means audio, video, images, and a lot of it is text. And I had written a full-blown research publication on how to work with structured and semi-structured data at Gartner. And if you are a Gartner client, you can look at that paper. It was written in 2021. And about 80% of an organization's data is actually unstructured, and most of it lies unused. If we talk about text data, it's hidden in emails, in blog posts, in content management systems, PDFs, PowerPoints, floating all around, right? And in my opinion, it becomes very challenging to work with unstructured data because most of the skill sets are trained to work with structured or semi-structured data, right? The tools, there are a whole bunch of tools, whether it's data integration, data processing, they're all again very focused on structured and semi-structured data, and that's where unstructured data becomes very difficult to work with, right? And understanding text, in my opinion, is challenging because of the complexities of the language and communication. There is, there is a lot of ambiguity. There are nuances. There are contextual differences, and it becomes even worse when it's multilingual, right? And a lot of text have idiomatic things, have figurative language that can be hard to master, and that's where the ambiguity comes from. And this is where I think things like knowledge graphs, which is sort of a machine readable way of organizing unstructured data, which maps your unstructured data to an ontology, taxonomy, vocabularies, to build a domain of entities and relate to that, right? And build the relationships. And knowledge graphs help to, in my opinion, compress all these linguistic varieties that we see in language into a set of standardized machine readable way of comprehending, right? And that's where I think the context now gets embedded with the data, providing you with semantics. So that's where I would think how,
Just to follow on with what you said, Sumit, is the text and language as it is carrying this knowledge. Semantic technology is the way that it actually, once you extract so-called whatever is encoded within these things, it kind of allows for you to formulate that in a machine readable. That's where the machine readability comes from, in terms of extracting it and making it machine readable, the knowledge that is part of this communication. And that's where this subject predicate object, those triples, and all of those things kind of are the offshoot of this semantic technology, which is kind of pretty much rooted in formal mathematics, and so it's very rigorous, so you can verify it and all of that stuff. As a result of that, you can actually find gaps in the knowledge that you may be looking for, assuming you had a prior ontology, and then you can also reason and produce new knowledge, and all that wonderful stuff comes about when you apply this semantic technology to this extraction, whatever the extraction that's happening against this language.
Let me start by just lamenting that 80% of the knowledge that we accrue is useless in the current state, and we need to find a way forward with semantics, whatever technology that is available, semantics being the key at this very moment in time. But how are we supposed to be competitive? How are we supposed to recycle knowledge? How are we supposed to train our staff if we're unable to access the reservoirs of knowledge and experience that we accrue day over day, year over year? I want to point out that somebody made a comment, Alan Michaels. He's saying IT should view company knowledge and industry knowledge differently. Do you guys have any comment on that?
View company knowledge. I'm trying to kind of make sense of this company knowledge and industry knowledge differently. Okay. I mean, you're separating the domains, if you will, and so I think that's is probably, if the industry knowledge is separated out, then these two can independently, can, first of all, IT is always changing, the knowledge about IT and all this tooling and all the techniques, things may be changing. They should not be clubbed with the real domain, which is the industry knowledge. Industry knowledge is the real knowledge before ever IT existed. Knowledge is independent of IT is there to manage knowledge. I hope that may be the root of where the question may be coming from. Any thoughts there,
Yeah,
Sumit?
yeah, I would say, Alan, to answer your question, I would say IT could view the company's proprietary private knowledge as separate from the industry knowledge. But in order to get to that knowledge layer from the data, right, from there is this domain knowledge, right, which is true for any domain. There is a lot of richness in the domain in terms of domain rules, domains business rules. Each domain has its own data, and that data has a domain related meaning. But only when you overlay the industry knowledge on top of it can you really enrich it to get better insights. And that's what knowledge graphs typically do all the time, right? There are a lot of ontologies out there, public ontologies. BBC, for example, uses sports ontology. In the legal domain, there are ontologies. There are ontologies all around. They bring that ontology on top of your own company data, which is your instance data, and thereby it becomes enriched. Not only it becomes enriched, but it also helps you to connect to external data sources much more meaningfully, removing the ambiguities, right? And that is where RDF based technologies, RDF stacks, which promote semantics, really helps. Yes, but there are challenges around this, right? You need to make sure that your proprietary knowledge is well preserved from a security perspective, right? So there are both aspects to it.
I just want to
Uh,
say that
yeah.
sorry, go ahead, Prasad.
Oh, I'm sorry. I actually misread the Alan's question here, but I think Sumit rightfully kind of led the way here. Absolutely, and one thing to add to what Sumit was saying is you can use these public ontologies, and literally every industry vertical has some sort of a starting point from out, public ontology of some sort out there. You can use them as upper ontologies, so to speak, and have your internal data be preserved with your own ontology. There's an extension of an external outside ontology, so you will have a much better, quicker starter. But as Sumit was saying, once you have your data be working through these ontology layers of ontology, upper ontology from outside, but separate internal ontology that is one way or another related to, or is worked off of the public ontology, lets your data be that much more easy to be integrated with other sources from outside, depending on however you want to kind of make it available.
I just wanted to add to that a little nuance through the perspective of legal. Right now, it's six different entities that are in this room. It's Summit, Prasad, Joaquin, and our contractual obligations to the organizations we are affiliated with. So that's where we see things in a different perspective. But if we have to look at things through the news, then we want to look at our relative performance with our organization relative to other organizations. So it really depends on the use case and what it is that you're trying to accomplish. I hope that gives. I hope we answered your question, Alan. But with that, I think Summit before this comment, we were talking about there's a deficiency of skills, of knowledge, of experience, and we need to find a way to cross that chasm, right? We're stating here, we're making the assertion that that chasm can be crossed with technology, but we also need to cross that chasm with education. So, what are your perspectives in that regard?
Yeah, and unfortunately, what we have seen is we have seen words like this. Data scientist is the sexiest job of the 21st century. That lasted for about 7 years, I guess, and now it's data engineers, right? In my opinion, I think we should promote the idea of not only data engineers and data scientists, but the idea of a semantic engineer, right? Who can understand the semantics, who definitely is a much bigger set. It's a superset of data scientists and data engineer, but they know the semantics, the skills around how to incorporate ontologies. Because we as human beings, very inherently know what is an ontology, what is a taxonomy. But when we go to the layer where we have to express it in technology, the words like ontology and vocabularies and glossaries, taxonomies, they often put people to, they stop thinking when when they start hearing those words. But we do that inherently all the time, right?
Mhm.
And this is what I would say, look at the number of courses that are there on knowledge graphs or semantic technology, right? Very minimal. This is where we need to change. We use this term called ELT, extract, transform, load, right? But as I've said earlier, data lakes are becoming data swamps, right? um, what we need to change is more to what is called as ECL, extract, contextualize. Because unless you contextualize the meaning of the data, map it either to your, as Alan has asked the question, map it either to your industry level terminology verbiage or specific to your company level. Unless you do that contextualization, data just remains very, very ambiguous, right?
Mhm.
So I guess if you have to work with unstructured data or semi-structured data, the other challenge is there is no predefined data model, right? A lot of us who work with structured data have a data model, right? And unstructured data and semi-structured data being 80% of an organization's data is extremely voluminous, right? It's extremely voluminous, and you have to use, right kind of technologies, because the scale is very, very large, right? Searching in unstructured data becomes so difficult, right? We can search in structured data, using SQL queries, from tables or CSV files. But searching in an unstructured data, when you have, let's say, swathes of PDF files, it's not easy. There's no very good tools out there, and again, doing semantic on top of it becomes even difficult. But yeah, that's what I would say. Prasad, please go ahead.
Yeah, I mean, so I think this is very contextual. This question of not having the right skills widely available to deal with this 80% of what is possible that can be put to use in a good way, right? If you kind of sum it up, that's where you're looking at. And what I would say is, it's interestingly text, is the dominant de facto way of transmitting knowledge, right? And so, and interestingly, once you have an ontology in mind, I mean, organizations, and inherently, as Sumit, you rightly said, we all come equipped with understanding. One way or another, as human beings, we have grown to accommodate, what the other person is saying, even if it's a new set of noises that have come together. One way or another, we negotiate to attach meaning to it, and from then on, it becomes, something that you can keep track of, and it starts becoming useful. It's so humans have done that. So one way or another, we are able to understand, because there is an inherent ontology. And again, I'll have to bring that. It's like, what are the concepts that are involved? What are the properties? How are they all interrelated? That is the essence of, what is being discussed when we talk about ontologies. Once you have that in hand, all this unstructured data need not be staged into some relational database in the middle, and so on. You can directly extract that as knowledge, and store it in knowledge graph, because knowledge inherently has a graph structure. Because a concept, it may manifest itself in multiple ways, multiple places, but it will collapse or resolve itself to one single thing. That's how we humans attach, identify it to be the same thing. And so it becomes a graph automatically. All we need is a structure to store this graph, and that is a knowledge graph. And so all the standards that we have, W3C standards, have wonderfully come, along the way, uh, to really mimic more or less, as much as it can, what our human processes kind of, take this raw sensory information to an understanding, to all these concepts, and things like that. Now you have RDF structures, and how they evolve into this graph, knowledge graphs. And once they are in a knowledge graph, your applications also need not be these complicated algorithms and all of that translated into some programming language. Once in a knowledge graph, most of your applications end up becoming traversals. It's and this travels now with the LLM, and this is where the context really plays LLMs can really interpret human language, and then that human language can really deal with what humans want out of this knowledge graph, so to speak, or the knowledge store. And these LLMs can really translate this human language into whatever the esoteric sparkle and all that really is required to interface with this knowledge store. So all that is now seamless, assuming it all works. Now you have LLM on one side taking in human language and going all the way to text, which is your primary source. All what we need in the middle is an ontology. And ontology need not be this big, monolithic, big, 4,000 classes and, all of that. You can start off with the basic concepts that are, as a bootstrap ontology for the domain, the corpus that you may be dealing with in terms of the text. If it is legal, for example, you start out with, and luckily, legal and any of these big verticals that we talk about, there is big ontology that is available already. And so with an ontology like that, with LLM in your hand, which is like a digital minion, is what I call it. All you need to is engage that to understand the ontology and apply itself to extract the knowledge that you are interested in, pertaining to the subset of what you may be interested in the ontology. So that is the prospect of what is out there for us. Automating directly going to this 80% of text that is available, or language, or these primary knowledge stores that are available, all the way feeding up to humans in the way that they understand. And literally along the way, all you need is this knowledge, because knowledge is intermediate format that it has to necessarily go through. Any other way, humans won't understand. And so once it becomes knowledge, you need to store it somewhere, and that's where knowledge graphs become extremely critical. And I think more people are realizing along the way that along with LLM, knowledge graphs are literally a parallel technology that we cannot ignore.
I have to take a step back and play devil's advocate for a little bit. So I think we painted a very clear perspective, a good background context. Knowledge exists in our heads. Okay. We put knowledge into text to transport it between people. Okay. That knowledge is stored in reservoirs that are untapped and inaccessible due to the current infrastructure of our data systems. Okay. The path forward is using semantic technologies to access this information. All right. So what? We've addressed a lot of what and whys, but how? Right? I mean, I think we're talking about there's blocks that exist. We can get off the shelf models of ontologies, models of human knowledge. But where do we begin? What I care about, if I were a business executive, is solve my problems yesterday. I want to access legal documents so I know who's dealing with who, transacting for what, under which conditions. I want to look at the news and understand which of my competitors are doing which deals. What companies can I buy? What are the people that I have to distance myself from because they might be dealing with some fraudulent activities, and that's going to penalize my organization. I care about the outcomes. So can you help me understand how we can accomplish that?
Yeah, if I can jump into just continue on what you're saying is, so what you're saying is how to, now that we know this text is carrying knowledge, we know people want simple interfaces to kind of extract all that. Intermediate technology and all that is secondary. And so how do we really make sense of getting this knowledge out to the consumers who are really wanting it to be in the easiest format that they're looking at? And this is where, and we talked about semantic technology and things like that, but in the context of the use case itself, extracting knowledge and making it funnel it all the way to the user, LLMs are extremely a valuable tool. So with an LLM, if you can make an LLM understand your ontology, and we will talk about, it's not such a big deal to kind of, come up with an ontology that serves your particular domain. LLM can use the ontology to interpret, the text, all the language, big mass of language and text and knowledge that is out there, extract that, and then formulate that in the format of, whatever that the users are looking for in terms of summarized answers, or, whichever the way we can because it's a LLM is a digital minion, as we said. All you need is one way or another make it work. Of course, there are some problems with all the hallucinations and things like that. More of it is corral and local in local use cases itself. We can use a knowledge graph to guide the LLM to be restricted to exactly what you're looking for. So every piece of input and an expected output, the mediation can be done through an ontology. Ontology is like understood way of saying what concepts exist, what properties exist, and things like that, and that are well understood by both the serving community and the consuming community. That's what an ontology is, pretty much, right? And so every handoff, if it is mediated by an ontology, then it can be seamless from whatever be the source and the target. And target is the end consumer, who are humans looking at all this legal stack of documents. And then if there is a legal ontology, and I can name some, having worked in these areas, Sali and LMSS. So once you have an ontology and you have this, let's say, a corporate law or corporate agreements that you're dealing with, you can look at the portion of the ontology that is in that space within this large ontology, make that be part of the LLM to use it to interpret, and of course there is an instrumentation that is there. Of course, as a company, we have a tool, that's called our text distill tool. Engage, just extract that, formulate that into these RDF triples, and go into a triple store like onto text. Is an extremely, and once all that extracted knowledge is in there, an LLM query, a user query can be interpreted by LLM, target onto text in this case, and then extract knowledge and produce the summaries that you're looking for. It's as if you are literally interacting with the text, right?
Yeah.
That's the how part. Yeah.
No, go ahead, Prasad. Finish up.
Yeah. So what I was saying is, the how part is kind of, these are the players that are required for the end-to-end chain. Yeah. Sumit, yeah.
Yeah, building knowledge graphs has not been easy. That's a well understood thing that has been echoing since the last 20 or so years, right? And again, knowledge graphs should not be taken off as a one-off engineering project, right? Building a knowledge graph requires collaboration between domain experts, data modelers, data engineers, and of course, you need the key sponsors as well, right? Um, the, However, over the last decade or so, a lot of tools have really evolved, and OntoText works regularly with a lot of partners in our ecosystem to help speed up the development of knowledge graphs, from tools with which you can collaboratively develop ontologies, taxonomies, maintain them. We also integrate with a lot of the data ecosystem around where your data from operational system changes. You may need to update the knowledge graph. We also help to build sort of virtual knowledge graphs where your data does not have to be copied into a graph database. We just build the metadata layer, and you can federate queries to the original source systems to power your knowledge graphs or to populate your knowledge graphs from a metadata perspective, right? So organizations need to choose, in my opinion, a development platform to provide development friendly sort of building and managing the things in a knowledge graph. Um, Typically, the main components, and again, I have written an extensive paper called Building Knowledge Graphs. And this was way before LLMs came into the picture. It was published in 2021, where I discuss how organizations can go about building knowledge graphs, right? And typically, knowledge graphs have sort of couple of inputs, right? Your raw instance data, your taxonomies, your ontologies, and you may need to incorporate your domain vocabularies, glossaries. But before even building your knowledge graph, I think organizations should ask them, or even business units that are building that should ask certain questions, right? Like, what are the products, or what are the systems or questions or what are the products or systems that will need access to the knowledge graph? What kind of inferencing, what kind of questions you are going to ask from the knowledge graph? What are the different entities and relationships you need to do bring into the knowledge graph, right? And again, building knowledge graphs, there is no one universal way of doing it. LLMs have sort of become a catalyst in helping to build knowledge graphs by and leverage the power of semantic models within the knowledge graph, right? Where you can pass as prompts the ontology, the taxonomy, and we at Ontotext have done a lot of enhancements to our product where we have integrated with LLMs, where there has been the complaint that Sparkle queries, which are the queries to query knowledge graphs, though they are very much like SQL, they could become complex. So now we integrate with LLMs to explain your Sparkle queries in natural language. We also have an interface where we do what is called natural language querying, or talk to your graph, where you can talk to your graph with natural language. It gets internally translated into Sparkle, and you get the answers back in natural language. You can explain a Sparkle query, you can explain a result. Not only that, unlike LLMs that do not provide provenance in terms of where the answer is coming from, we have within our knowledge graph platform, when you get an answer to a query, you can figure out the lineage in terms of where are we getting that answer from, which particular subgraph of the knowledge graph are you getting the answer from, right? We also have ways where you can, let's say, want to classify a certain text. You enter the text and you say to the Sparkle query that give me the keywords in this text based on a given taxonomy. We pass the name of the taxonomy and you can get back results from LLM which are validated by the knowledge graph, the set of keywords based on that taxonomy. So we have done all these different kinds of integration where you can also prompt and say to the LLM that I want, this is the way I want my format in which I want my knowledge graph to be described. Pass the ontology, and you get you can generate the knowledge graph. However, in my opinion, there is still a lot of work going on in this area where you leverage LLMs for knowledge graphs, because in my opinion, a lot of the LLMs follow this long tail curve, right? Where it can easily do a lot of the common things very easily, right? And we tend to get excited that yes, it can solve all problems. But then there is this long tail where a lot of difficult things become very difficult to do with LLMs as well. So, and there is also the question of error handling. So that is what I would say. Sorry, a long description, but I thought it was very relevant.
Yeah,
Allow me
absolutely. Yeah.
allow me to entrench myself even further into the devil advocate shoes. So you guys are describing a lot of capabilities. You guys are describing a lot of the methodologies that is going to support the adoption of these technologies, right? There are building blocks. There are platforms that ease the use of this without having to understand all the mechanisms underneath. There's train hands that can facilitate the development of ontologies and implement this in pieces. I'm going to continue playing this role of executive. Okay. People told me that if I get data scientists and build these data lake houses and warehouses and all these things, my problems would be solved. But they've turned into data swamps. Okay. Can you promise me, can you help me understand if my lawyers are going to be able to solve more cases, if they're going to be able to look at more contracts, are they going to be able to make more money? Can you tell me that my analysts doing research for private equity firms or just getting sentiment over the market changes, they're going to be capable of answering questions faster? That's what I care about. I'm paying money here to get you guys to build something for me so that I can get value for my business. So can you guys help me understand that?
Yeah, before that, I would say before Prasad starts, you want lawyers to make even more money?
Right. So that puts it in the right context here. Yeah. I will actually start off where Sumit left off in the previous one, and then hopefully I'll be able to add to what Vakeen is saying. Um, and onto text is a relational RDF semantic database centric company, right? And rightfully that is a wonderful intermediary that captures all the knowledge and stores it and so on. As a company, Lead Semantics, what we do is this ancillary additional stuff that deals only with text. So we are rooted in text. So we take unstructured data as input, and our tool, our product called Text Distill, understands this text according to an ontology and produces this knowledge in RDF, the standard format, to be put into onto text. And then and not only does it give a natural language interface to end users to take their natural queries to have it go against the RDF data store in the middle. We also give the provenance back into the source text, and the provenance itself is to the literally the phrases and clauses that are the source or the raw starting points for the knowledge that is in the knowledge graph. In that sense, the query results as they come back to end users to their natural language queries, you can literally see as if you have underlined or highlighted within the text documents where the answers had come from. And that's the the tool support that Text Distill has. So it completes that end-to-end starting point of text to a human language interface to your query. So, and knowledge graph in the middle is the intermediary for us. I mean, it wonderfully mediates this entire back-to-back chain, because that knowledge, more than the tooling, it is like we are routing. It's as if human is communicating to a human. That is the operative thing that we are mimicking. Human is producing natural language query. Human has produced this text one way or another. Even if it is Chat GPT that may have produced, assuming it has been qualified, corrected and things like that. It is a human output. So human output to human output is what we are making it happen. And as we started out at the beginning of our discussion, it's the knowledge that is actually flowing through this language. Somebody has to interpret it, and when you interpret it, it becomes knowledge. And so now we have given through semantic technology an actual artifact, something that you can store and integrate with other such artifacts from different sessions and so on. So it's a very powerful end-to-end value chain that we are creating with these tool set that we are talking about.
Yeah,
Yeah.
and I'll give you a couple of examples. And again, I'm not a person who's very well knowledgeable in the legal domain, but I know there is something called a global legal data set that is a linked open data that is publicly available, right? And also there are legal domain ontologies, right? And legal data is all about text, right? It's so text heavy, right? Where there are mentions about contracts, and contracts may contain a lot of, for example, contracts can contain a lot of reusable terminologies that needs to be unambiguated, right? And with knowledge graphs, one can structure these legal documents which have a lot of these entities and the relationships in with knowledge graphs, right? Where you can model those documents as knowledge graphs. And for example, you can also break it into pieces, because knowledge graph at the core is built on top of triples. Triples are very low grain ways of representing facts, right? With subject, object, and a predicate connecting them. And now, with breaking out your legal documents into granular forms with these triples, you can do you can become very powerful in terms of quickly figuring out if a contract is valid or not, based on certain parameters, whether the date, whether it's been accepted or not. And knowledge graphs allow you to do these kind of things, where you can reason and do inferencing, right? Which lawyers and the legal system does all the time, right? For example, if I say all humans are mortal and Socrates is a human, it can quickly figure out Socrates is mortal too, right? Because that's the way knowledge graphs work in terms of the power they get, right? Now, you brought about that idea about this is done through what we call as model driven extraction, where we have developed certain use cases where you can quickly detect risk events, for example, especially in the financial domain, where mergers and acquisitions can happen, or where certain people are leaving a company in mass numbers. And these have a lot of implications in terms of sentiment analysis, risk management in the financial domain, their economic indicators. And we can do all this because we have modeled these risks as ontologies with a knowledge graph, and then we can leverage language models, large language models, to quickly do what we call as zero shot learning, where you can change an ontology and still detect the events and figure out what are the downstream impacts based on that.
Absolutely, absolutely. And just a case in point, one of the use cases that we had used our tool quite a bit is against news. News as it exists in finance and business domains. As it is flowing through, there are all these business events that need to be detected and things like that. And events are these abstract things, three or four facts together, when they appear in a particular context, they promote themselves to be an event. So if there is a soccer players all show up in a particular time at a particular location, and them to be soccer players, then you could probably extrapolate that to be an event of a soccer game or some such thing. So soccer game itself is abstract. So where I'm going with this is, so these events to be detected are need not be always labeled, and you may not find a mention of a labeled event in the running course of a document or in a narrative or a discourse. You should be able to put together, and as humans we do that all the time. And and such is the power of, if you can model through ontologies, all these kinds of things can be extracted through fairly narrative text, and then reproduced as real knowledge that people can relate to. And so extracting, and it goes back to Joaquin, your challenge in terms of, you have all this and you want to increase your business for your reading all these documents. Without automating extracting knowledge out of these documents, that is the proposition that you cannot attempt, because of the sheer volume that Sumit has mentioned, right? That is available and is all around. And automation is now at hand, with the technologies like ontologies and knowledge graphs and LLMs. you know and all these things are in place. And with a tooling like ours, and I would hate to plug in at this, but I think it's pretty apt. Text distill is one of those things that puts literally these ideas together in an automated fashion. You give it input as text, output as knowledge graphs. And so that's the proposition, and one of those things can really start making use of the text that is lying around.
I want to say, I like you guys. I like you fellas. Okay. I want to make money. And you guys are giving me a clear perspective that there are these capabilities, that there's these automated ways of resolving these issues, and it's going to be based on facts. But let's boil this down to brass tacks. Okay. I want to know, can we piecemeal this? I don't want to get fired over making the wrong investment. I don't really fully understand this technology. And the only way we're going to find out is that we've, put a little bit of money into this. So what is the minimal commitment to realize something? I mean, all I want is my lawyers or my analysts to be able to answer questions faster. So can you guarantee that in a certain time frame? Can you give me some level of confidence? I just need to know so that I can take this back and make the case in my business.
I can smell the proposition. I will let Sumit jump in here. As I stressed upon, and Sumit has pointed to it as well, the tooling is available. The best practice, the knowledge of how to put it all together is available. and Sumit has a product to sell in this area. We have a product to sell in this area. We work together in terms of extracting this knowledge out of this plain running text that you may have in your law firm or whatever the form, and then make it available as a natural language interfaceable querying system. And so something like this typically in our experience is like a proof of concept, a targeted proof of concept that maybe has a pile of documents of a particular domain, and then starting ideas of what concepts and what relationships are of interest, what types of sample queries that the user community may expect out of these documents is a wonderful starting point to prove through this POC. And it even though it may have been really complicated in the past, things have turned the corner. So with the advent of real knowledge, and of course you need skilled hands and things like that, and of course we are representing some skill groups here. uh, Teams like us, we can probably go through such a POC, and we have done pretty serious such POCs that have resulted in wonderful outputs directly from text and language as a primary source and queryable interface on the other side. That would be a natural way to kind of for you to see if this is practical to unleash it across whatever the rest of the corpuses you may have.
Yeah, I would like to add on top of that. It's basically you need to even before I go there, I think one of the things I would say is today data ecosystems have become like sort of data jungles, right? There are, if you look at, if you follow a very well-known analyst, his name is Matt Turk. If you look at his data ecosystem landscape, PDF file that has about 1,400 company logos across different areas, from data integration to data consumption, right? And data engineers, data scientists are struggling to figure out which tool I use to build an end-to-end platform that can grow, scale, and as business changes, I can quickly do this. But one of the important things they are missing in all this, as I've been always saying, is the contextual aspect of all this, right? And technology is just technology like data lakes and data lakes, lake houses will not be able to solve this problem. You have to bring in a knowledge driven system which is based on semantics, metadata, semantic annotation, things like that, to really make you successful. So one of the things is you split a large complex knowledge graph into what we call as domain bounded contexts, right? There is this whole paradigm called domain driven design, where you don't try to boil the ocean, but you use a specific domain or a specific department to build, to have a team of domain experts who can model graphs, who can write code, write the API services, to build a system that you can, as Prasad said, do a POC or a proof of concept at a domain layer, right? Begin with simple use cases, single use cases. Identify the content that you probably are looking, build an ontology, or even in most cases, import external ontologies or taxonomies, and map these relationships across your data, and use these ontologies and taxonomies to map your relationships across the data, right? And the idea is to, again, use and reuse to generate the semantic metadata. At OntoText, for example, we have very well tested, battle tested tools to integrate data from your source systems. We use a tool called OntoRefine, which is based on OpenRefine, that can quickly help you to map your structured or unstructured data into the kind of graph you want to build, the knowledge graph you want to build. We also have what is called as a tool called Metadata Studio um, that you can leverage to work on your unstructured data and generate annotations, all the semantic metadata around that text. And then you can put them together. So we have the tools to quickly get you up to speed, whether in terms of an enterprise wide knowledge graph or in terms of even if you want to do a domain specific, a departmental units knowledge graph.
All right. You guys have given me a lot of food for thought. There are tools, there are standards, there are reusable components. We could start with a POC. You're going to be able to plug that POC, that ontology development, this infrastructure into my existing ecosystem. I have one more question for you. Is that POC a throwaway? Will we have to reinvest in some new infrastructure down the line? I just don't want to. I want to make sure I'm not throwing away my money.
No, if you ask me, I mean, and I'm pretty sure with Ontotext as well, the tools that you use, the ontologies that you start out with, and as Sumit rightly pointed out, oftentimes you can start out with something that's already existing. Literally, there are thousands and thousands of ontologies that are out there that you can use them as a starting point. And for your POC, that may be what it is. And in any case, whenever you are adding or doing something with it, you are putting your domain as a driver anyway. I mean, that is the target to replicate in your ontology. And so that will be reusable as well. And so everything that you do in a POC, and that is one other beauty with knowledge graphs and knowledge technology, so to speak. Knowledge is more than just the tool. Once the knowledge is produced, you can it's an artifact. It's that you can keep add it to other things. It has its own value, unlike some data, even information. Knowledge has context, it has a meaning, it has some purpose, and that doesn't go away. And so that gets real value even through time, even past the POC into your real projects.
Yeah, absolutely. The whole idea about using and reusing, right? Build reusable components, right? Just like you do software development, where you abstract out the concepts and see what things can be reused, and then leverage them across different departments or different solutions you're building on top of knowledge graphs, right? Yeah, that is how I would say. And your POCs should never be throwaways, right? Where because it's a stepping stone. It's a stepping stone both from an skills up leveling perspective, as well as understanding what is possible and what is not possible in terms of the capabilities of graphs.
Okay. Uh, from here, from the POC, we can evolve, we can extend, we can continue to shape this out as new use cases are identified, or if I come up with any new ideas for my analysts, or they come up with any more questions, I'm sure that there's ways that we can continue to expand this proof of concept. Um, Great. Well, I think we've made a solid case for investing in this collaborative service. And do you guys have anything to say around working hand in hand between OntoText and Lead Semantics?
Yeah, it's a wonderful partnership between Ontotext and Lead Semantics. Ontotext has this RDF semantic knowledge graph database as a central tool. They have other tools, as Sumit mentioned. And lead semantics is text distill. We are so focused on just unstructured text as a source and extracting knowledge in the standard RDF format. And so this becomes a knowledge sink onto text, the database for us, for our pipeline, and the source being, your regular text that's lying around. And so this is an end-to-end kind of a tooling. And text distill, which is our tool, has this other interface that takes in user interface as natural language queries, and then translate it into Sparkle actually, directly to, like onto text, and then, have provenance links back into the text. So this is the tooling that's all around. And so folks can reach out to us in at Lead Semantics or onto text if they have a POC in mind, anything that we can add value to.
Yeah, I do see a lot of possibilities, right? Onto text, the name, as you see, it's built is of two things. One is onto, which is ontologies, and text. We are also very good at text analytics. That's been the bread and butter for us. And I do definitely see there is a lot of opportunities in terms of collaborating with your capabilities of text distill, and and having a good synergy and a win-win kind of a partnership.
So we start out with the text, we convert that text into knowledge, and then we can make that human and machine interchangeable, develop a POC, and use our platforms and tooling to make it accessible to people who don't necessarily have that technical background. Um, yeah,
Exactly.
for more information or anything like that, just contact Prasad or Summit and we'll get back to you. Thank you guys for tuning in, and I hope you enjoyed the back and forth dialogue. And you don't hold it against me that I played devil's advocate.
No,
Thank
that's
you.
great. You are not a lawyer yourself, so we'll let you go. Yeah. Thank you so much. Yeah. It was a
Thank you.
pleasure, Sumit. Yeah. Thanks,
Yeah.
Vakil.
Thank you, Prasad. Thank you, Joachim.